Okay, so I will talk about certain things that you should be knowing when you design mobile apps. And mobile apps, presumably most of the mobile apps do not work in isolation, and that's what I want to prove today. There will be some code samples, some demos. So if you are a developer, I think that makes your life easier. Okay, a little bit about me. So I work with Laurie Harris. I lead their cloud services team. I have spent time in mobility, release products for them, and I also run the Amazon Web Services user group in Bangalore. And I think you can use the Twitter handle MDS for tweeting about this talk. So this is the agenda for this afternoon. So I'll be talking about two different worlds, and the mobile world and the backend world, and why they cannot meet each other, and we'll try to bring them together in this session. I'll put the argument of why mobile backend services are important for apps. As an app developer, you should spend time understanding these services and how they can be instrumental in terms of delivering new features and engagement in your applications. We'll also look at what's available right now, right here, that you can start working with these services, and spend some time, look at some of the popular services, dig deep in them, see some code samples, see practice sessions in that, and finally, we'll see what are the loose ends where these services fall in and what you should be doing to avoid that. So the first thing, the two worlds, and let's unite these two worlds. How many of you are already developing mobile apps or have done mobile app development in this crowd? Okay. How many of you are like newbies, have not done any mobile app development and here to probably put a point in their resume that I do mobile app development? Super, that's really good. How many of you to learn something and go back and apply it in projects? Great. So that's with the most number of hands. So this is how a typical mobile app developer looks like. Okay? If you do a research, that's how what I did. Before I came to this presentation, I found people and talked to people who are actual mobile app developers, and this is usually the face of a mobile app developer. You can see the type of drinks he looks like. But the main important point bringing this here is type of ideas and practices does this app developer brings on board. Talk about user experience and design, mobile operating system, social integration, location services and graphics. 85 to 90% of time, mobile app developers have to deal with these issues, and their life is set in those issues in totality. Then there are other developers, which I'll talk about in a few slides. How many of you can relate to this? How many of you are these type of developers? How many of them like beer? Great. So it's a very less hands weird. Okay. So that's what the exclamation mark is for. Then come the other set of developers. Okay? These are the typical backend developers. Okay? So there is no pun intended here. If you go out and meet backend developers, they have spent their beard and life fixing issues in the backend, optimizing, making sure there is a storage attached in some system, and that's how the life goes on. And then they meet these guys who are very happy. So these guys are cheerful, right? So what are their concerns and what they do on a day-to-day basis? Scalability, distributed systems, fault tolerance, virtualization, and database. And I belong to this category. Okay, don't see my beard because I just shaved it in the morning. Okay? So this is the typical developers. They opt for whiskey, scotch. They're not a beer type guys, okay? So how many of you are backend engineers who have spent some time building backend solutions? Wow, that's good. That's not a background or interview. Okay, so these are top things a mobile app developer and a backend developer would fit in. Why will a mobile app developer be in more highlight compared to a backend developer? It depends on situation to situation. When you're talking about mobile apps, a backend developer remains in background, but it's basically the heart of the system. A mobile app developer takes the shine, right? You develop the next best UI interface, and that goes in public. People enjoy Angry Birds. They do not see how data is being generated by the app and what is happening in the backend to sustain that gameplay. And then you have a backend developer who says one and often sends a tweet that, this guy does not even know what is happening behind the scene. He should talk to me. Angry Birds is not angry because of this guy, it's because of me. Okay? So I want to make sure that you understand and have empathy to the backend developer and talk about what is the best thing that we can bring out in both the sides. So why mobile apps need backend services? So this is one of my friends, and I asked him the same question. He always dreams of the same thing. He says, I want to be the next big application developer, build an app that beats the hell out of all these big mobile apps. So what he does, he starts planning the activities on his drawing board, makes some ideas into what he wants in his next to-do list app. So he wants to have a task list, pretty common. He wants to have task reminders that can be shared. So I can ask my wife to remind me that there is something that I have to do at a particular time. I can put social reminders. I want to do cross-devices reminders, and I can do something like a public task list for my group of people. So this is something that he thinks of the USPs that his app will bring on board. So what are the things that he needs to have on the mobile front to make this happen? First, the local reminders. If you have been building on iOS, Android, BlackBerry, Windows Phone, anybody Windows Phone developers here? Great. So the app reminders, the reminders on device, native reminders, is one of the key features that needs to be explored from a device. If you are building an application of this kind, user interface, of course, nobody denies that. Local storage, so you need some amount of local storage to persist information about the states, when you move from one state to other state. And lastly, the location services. So in case you want to remind this guy that he has to do certain thing, he has to buy a milk packet when he's out on the street, you can do that. Then, what are things for this mobile app developer that needs to go backend, that needs to sit with that old guy? First, shared storage. Because this guy wants to develop an application that will have a cross-enability across multiple people sharing a common reminder, he needs a shared storage. A shared storage accessible to all the users of this mobile app. He needs push notifications that can prompt you to do certain action based on the reminder. User login, you don't want to save the user information on the device, because if the device is lost, you don't want to restart from scratch. You want to persist it outside on a third-party system. And lastly, social. You want to bring social integration inside the app. So apart from these points that he wants to build into his app, what does mobile backend has to bring offer to the mobile app developers? Firstly, device independence. If you see the statistics in US, at least every single person carries up to 2 devices, which could be a tablet or could be 2 different phones. So you need a cross-device integration, and not just with devices, but it could be your personal computer, your television, your refrigerator, and as M2M is increasing, you will see this happening more than often. So you need device independence. You need to persist the state of the user of the entire engagement on the device outside on a third-party environment, on a cloud service, or on a backend. You need to offload computationally intensive tasks. There was a phone that came in Chinese market having 4 cores and 6 GB RAM. Okay, and you can buy it on eBay. This does not mean that you will do computationally intensive jobs on that, which means I don't want to do something like a speech recognition on the fly on the device, which may hinder the performance of the application. And I want a way to offload this into a third-party system and then be able to interact it over either an HTTP or a typical protocol that you use for communication. State management, very, very common use case when you talk about backend as a service. You want to persist the state of the user, of the engagement happening at the device state, and put it offline from the device. So what happens if he resumes back or he comes back tomorrow to that interaction, entire state can be brought in back to the application. Integration with services. So you're talking to Facebook API for doing your open graph access to your friends' status updates, or you're doing an OAuth to your Twitter to get your status updates for tweets. Any integration requires an external access to a backend. You do not want to do a point-to-point. In that case, 100 million applications deployed on 100 million devices will make 100 million calls. So typical software architecture does not allow that. It's a bad design. So you need a common front end, a common backend entity that can disambiguate this, abstract the entire process, and be a broker for you. And again, limits of the RTOS environment. We know we have reached a level where we have four cores, 8 GB RAM kind of devices coming in the hands of people, but there are limits of the real-time operating system. When the phone call comes in, you should not be playing Angry Birds. Especially if your phone comes from your wife, you should not be playing Angry Birds. So there are some limits to RTOS. And that's what you should exploit when you design good applications. When there are high priority events, you do not want your application events to be running at that particular time. You want to offload it and commit back on the device once the user is back from the phone call or any high priority task that he has. But more than important of needing a simple backend, he needs scalable backend services. Why? Unpredictable usage. I build the next Stardust list or to-do list app, and I don't know, I think maybe it will be 100 users, and suddenly there's a viral spread that somebody found something interesting on the app, and now there are 100,000 users, and I have to talk to my old guy, fixing servers, adding capacity to my backend. I don't want to do that. I want to make sure that old guy is relaxed. He can enjoy the whiskey or the scotch without worrying about adding new capacity on a day-to-day basis. And that's what we want to take here as the premise for talking about scalable backend services. We want someone to take care of the scalable backend services because it's a hard problem. It's a forever task for a backend. That's why you see the old beard. It's a hard problem. And somebody should be there to make sure that you are able to deliver the right experience to the end user without worrying about the granularity in the backend. So what is available? What is currently available in the backend services that you can exploit right now? Storage. Thanks to public cloud services, you are never short of storage capability. That means rather than finding out a local storage environment or some hosting environment does that, now people have access to infinite storage. If you have not, how many of you have played around or worked with any public cloud service like infrastructure service, storage services like that? And the unpredictable usage can be taken care through a storage service. Second, user management. Again, I've talked about in detail. I'll show you some examples ahead. Messaging. Device-to-device messaging can be enabled through an intermediary sitting outside of your application and able to interrupt or become a broker for your interaction. Notifications. You still, if iOS developers are still in the hands of Apple to make sure the notifications work, you need to still remain in that periphery. But other developers, other platforms, Android, Windows Phone, have that relaxation of able to use push notifications outside of Google ecosystem, and they are scalable, mature public services which you can take advantage of to do this implementation. Social. If you look at what Sujay was talking about before this session, he was talking about BBM capability inside the application. BBM capability is powered by a backend owned, governed, managed by BlackBerry. And for adding social features, you need entities like Facebook, Twitter, LinkedIn to be able to maintain the social structure outside the phone. And that's what these services provide you. Moreover, if you're using multi-social services, you do not want to do a point-to-point between your phone and Facebook, LinkedIn, Twitter. What you want is a mashup and a system where you are able to invoke social engagement with one API rather than worrying about talking bespokely to different APIs of either Facebook or Twitter or LinkedIn or other services. Analytics. There's an interesting use case where telecom organizations are opening up their internal analytical platform for end developers. Why? If I am able to expose how my users, how my subscribers are able to use services from my end, what type of service they more often use in terms of more call, going from a local to local, more messaging at a particular time period, or value addition services, I can ask my end developers, my third-party developers, to capitalize on that and build value adds around it. That is first idea why analytics have become as a service from telecom firms, and this is happening everywhere. If you want to build, if you want to do data mining on terms of finding out what is the right usage patterns of this group of people who are using my application, I don't want to run it on my device. I want to run it on an external system or an external entity where this processing happens, and I will be able to trigger it out, trigger an event on my phone. Anything and everything, which means this is the rise of mobile backend as a service. And this is not another buzzword. Mobile backend as a service has been always there. It's just a new, probably a old wine in a new bottle. But the way mobile backend as a service have, come in and become prominent in terms of users using the service in the first hand rather than building themselves proves the point that it's here to stay. And for all of your developers right here needs to tie into these services to build better and engaging applications. Great. We have seen all this. What we want to do now is want to spend some time looking at what can be accomplished from some popular service of this kind. There are multiple mature public cloud services. One of them you have seen this person speaking about, Vice President speaking about in the keynote session today. But there are many others. It's growing. There are 50 different services just from India in this space. And 2 of them very mature right in Bangalore. So this service is increasing daily, and it shows the promise that investors see the reason to spend money in these startups. Again, this does not mean this is a niche for only small companies who are exploiting this. There are bigger companies who are acquiring such scalable backend services and give the power of mobile backend services to end developers. Today, I want to talk about one of the very common services used by most of the first-time backend service users, Parse. Parse is a Y Combinator funded startup in 2010, early 2011, and what they came out to build is the same set of principles, same set of service which I talked about: storage, notification, user management, and location services, social integration, all being given to you as a service. Which means today, if I want to add a social integration, what I have to do without these services is I have to go out, open my console, add Facebook SDK, build SDK services, log in, authenticate it. Where do I persist this information? It remains in Facebook. Tomorrow, I need to onboard Twitter. I again start building Twitter integration in my app. With social integration as a service provided by services like Parse, it has become a unified order for me. Second, doing notifications, doing device-to-device notifications or closed group notifications is being powered and made democratic through Parse and services like that. So what we will do is quickly check 3 services of Parse and how you can employ in your application right now and develop engaging features. So what I will do is I quickly go back to my Eclipse. I have been a heavy-duty Android developer. I built something on Windows Phone as well. But for today's demo, I want to show something on Android. The good part is most of the notification services from these large and mature providers can work on the emulator as well. But on iPhone, you need a device. iOS simulator does not give you notification services running inside their simulator. So what I can do is I want to use the Android emulator and show you some samples around it. So I have a ice cream sandwich build, and let me talk to you about what I'm going to do right now. So when you want to use Parse services or Parse.com, which is a backend service, the first thing you should be doing is obviously Parse.com has all these services exposed as REST API. But if you don't want to go in the API level and you're happy with the SDK, there's a simple jar file or Parse SDK that is downloadable from the site, and that sits inside in your package directory of your application. Let me go to the properties. So you see a Parse 1.1.6 jar here in my package. And the next step to do is to go to your manifest file in your Android. How many of you have been developing on Android or have done some development on Android? Okay. And how many of you have been done development on iOS platform? Fantastic. So let me give comparisons. So what Parse requires for the demo that I want to show to you is first idea about which device I want to invoke the service from, right? So parse has a very simple backend interface from which I can manage all these services. So this is a parse backend service, which means it has access to the data browser and push notifications. On your left, you can see a classification called class, which means if I want to create a data structure or a data model, I do not need to retain on my phone. I can retain it on the cloud, on the backend service. So you see the class order here. By default, you get 4 orders or 4 data models called installation, role, test object, and user by default, which means these are given to you as part of the definition of parse. The user, as obvious as it sounds, does the user management. You see here, it is giving you a premise of a database table. So what you have is the object, username, password, and I can manage all the users of my application right from this front end. Installation manages the number of device users of your parse backend. So the typical engagement goes like that. If I want to use parse services, I first create a namespace or application namespace on the parse account. And once I created the application, I get this empty template from which I can do data browsing, which means all the data models which are kept in backend. I can do push notifications, and I can also manage how my system, how my backend is being used. So up to 1 million requests and up to I think 100,000 push notifications, parse is free. And then you have an order of $150 that you need to pay to parse. And most of the most of the backend and service providers work in the same model. So coming back to the other developers. So Android Manifest, which I show you in front of me, is the entry point to configure the parse plugin or parse dependency which I've added. I am asking the Android platform to give permission to my application to access internet, to access certain entities, certain events. So on my Android platform, I have an event by the name called receive boot completed, which is called the intent. And I have to give permission to vibrate the phone in case there is a message or notification comes on device. And I need to be able to access internet. And I need to be able to access the network state to check if there is connectivity or not. The second thing I need to do before I start developing using parse is I need to register a service in the manifest. So by design, the parse jar, which is dependency, comes with a push service, and that you have to configure as a service endpoint in your Android manifest. Lastly, you have to configure a default receiver. So this receiver comes bundled inside the dependency. If you want to build your own receiver, for example, what I want to show to you is a notification. And when a notification is arrived on your phone, you want to do something very interesting, invoke some services, open some new layouts. You can either configure your own receiver or you can use a built-in receiver from parse to do something about it. So what you do here is I am giving this receiver access to work on 2 intents or 2 actions. One is the user present, which means the user is accessing the device is not sleeping. The second, boot completed, which means the device is ready to be processed, ready to have a new notification. So if you're not coming from Android platform, don't worry about it. This has exact replica in the iOS platform on the iOS turn, and the techniques remain the same. Which means the first step is to configure your endpoints, give the permissions to your application to access internet, and all the other required services for parse. Once you have done it on your Android manifest or your configuration, what you have to do is, for my application, what I've done is first wanted to show you how to log in using parse backend. So my device, my application, does not have any backend running on my laptop or any external service. Everything is off the parse backend services. So what I've done is I'll show you the application first. So this application has a simple login page, and what I want to do is allow the authentication to happen with the backend of parse. So what I'm doing is on the login button, I am using the parse API to get access to the username and the password. So keep in mind, this username and password is already available on the backend. If you look at the previous page, these are the existing username and password already available. One which I created just before the demo. This is already available, and you can create any number of such username and passwords, totally unlimited. Coming back to our demo. So what I'm doing here is, I'm saying login with the background. So by design, this login background API or login background method validates against the user data model with the username and password which I've collected from the UI entities. And I'm saying once you log in, call me back with the method done. And this is where I basically go to the next screen. Otherwise, I give it an error. Very simple use case. So if I come here, I will put my username and it has a password. You see the same password. What I'll do is I'll log into this box, log into this. So in the backend, what Parse is doing is taking these credentials and it's moved on to the next screen. So if I come back, I'll put probably a wrong username. There's a fault and it catches here and probably gives me a message, incorrect login on my emulator. So which means I've logged in correctly in the previous login. Let me go back. So what we do now is do some other interactions with Parse services. But let me come back to the code. So two simple steps. You use the Parse user, basically a built-in interaction already available in the Parse API. Use the login method, pass your credential which you have collected from the UI, set a callback, and you're done. So you can also instruct from right here, from this device, from this application, to create entities on the user backend, the user data model. So once I'm the second screen, what I'm doing is I want to show you notification and do some persisting information in the backend. So how does notification work using Parse? Let me go back to my push notifications window. So push notifications work with this receiver which I've configured in my Parse application. Here is the management console which shows all the data which have been sent to this application till date. Each time my application needs to register for a receiver notification on a channel. So here, by default, you have a broadcast channel which is the public channel, right? You can create your own channels. You can say a channel 1 for one user, and you can create unlimited number of channels. So using that channel, if your mobile client, your application sitting on a device is subscribed to that channel, any changes, any modifications I do here gets pushed down over the network to this device. So what I've done in my code, let me go to the next screen, is, let me just bring up this. This line called parse.initialize contains one set of information, which is the user application ID and the key. This is available from the parse side, which means anytime you create a new namespace or a new application, you will get this ID information. And this is the unique ID which needs to be provided. In case you want to do a REST API or web services interaction, you have to pass it, sign your call with that. Otherwise, this is a handy way of doing it from the SDK. Let me show you where does this happen. Let me go to settings of my application. Let me go here and I'll quickly create some applications for you. Okay, so this is my interaction. So what I can do is I can quickly say, let's create one more app here. I can put a name, Hello World app. Okay. Once I create the Hello World app, you will see a set of credentials being created with me. So you have the application ID, the client key. So what I'm doing in this case, I'm using an Android client, so I'm using the client key as a second parameter to that initialize method, and the application ID has a unique identifier for my application. So this is the key for the other user. Let me come back to the mobile test dev one for which I'm using it. You see this application ID and the client key is being used in this code. So this is the first step that needs to be done even before you do any authentication or any notification. You initialize your parse, which means it interacts, it creates and registers. What it does is in backend, it makes a call to the parse backend and informs that there is an entity, a new device by using the same credentials. So please allow this device to talk to the backend service. once this is done, I can start creating other assets of it. Let me come back to the second screen which I was working at. So what I have to do once I have initialized and now I have shown you how to authenticate, I need to get some local notifications done. One way to do that is to use a built-in service called the push service and call the subscribe method. You have alternates of the same kinds in the iOS platform, so don't worry about it. What you have to do with that is, either you can say, I want to listen to anything and everything, which is your broadcast channel, or you can specify specific channels here. So if I specify a specific channel which I have created in the backend, and I push a message to that, my application is able to receive it. Here I am interested to do a broadcast or any message sent to any device, I am able to receive it on my phone. Once I've done that, once I've done this push subscribe method, my service has already been registered, which means as soon as I do an interaction from backend, an interaction happens on my device. Let me show you about that. So let me go to the push notification page for the parse backend, and let me say I'm selecting the broadcast channel where I selected channels, and I'm putting a normal message, not a JSON message, saying that hello NDS, and I am selecting one channel here. So I've just sent a message, and it comes on my application notification, and it also comes on my device, which is also configured. I'm not sure how many of you see it, but it's just this hello NDS. So there's a message here. Now, what you can also do is from your mobile client, you can make a call to create a push notification, which means you can do device-to-device interaction. If I want to create a closed group calling system application or a messaging system application, from my Android phone or iOS phone, I can ask the backend to push some notification to my friends. But let's say you are building a next new application called a group messenger. And what you can do is basically create groups of people, name it. So by definition, that name will be a broadcast channel against your group. And if you send a message, everybody gets it. And that's how easy it is to develop using parse. So,
big question here.
Yeah.
So when the application starts, you are registering with the ID and you are requesting the parse system to allow communication to the backend service, right? So for applications which allow offline caching and offline starting and using the applications, would it still allow the user to continue, or would it already constrain that they should be connected to the network?
So that's a good question. So if you are offline, what it does a disk cache of all your requests. So you do not need to wait for it. As soon as you get a connectivity, everything gets pushed on. And if you make multiple notifications, everything is stacked in that order. Okay? Great.
A question here.
Yeah,
so is it similar to, or does it integrate with Apple notification service?
Yes, it does. It does. So you can also make a call from your Android application to iOS users, but you need the private key for doing that notification.
Even Urban Airship is doing this similar kind of stuff.
If?
Urban Airship.
Urban Airship is doing this. So
similar or Juneja?
Urban Airship is doing the exactly same. So I took one of the examples of parse. So user grid is doing that, Kenway is doing that, Key is doing it, everybody's doing that. Okay, let me come back to that part. So the second parameter of this subscribe, before I go ahead, is what needs to be activated when I get a notification. So you want to activate a different screen. Let's say you get a notification, you want to do something about it, you can put a handle here. The entity which will be called, or the view or the entity which will be called from an interaction point of view, once you get a notification. So if you see on my emulator, I see a notification, and if I tap on that, I go back to the same screen because I registered that as the activity which gets a callback. Okay, coming back. The second thing I want to do is save some information. Now what I've done in this interaction is I've created a very simple, let me come back to this. I've created a very simple object called GameScore, and that is possible using a class called parse object. So demo info is the class. You have seen 4 classes there: the test object, installations, users. Demo info is my own custom class, and I can create my own schema. And it's an elastic schema, which means there are no fixed columns. You can add as many columns as possible. Okay? So what I'm doing here is I'm putting some state information and I do save in background, which means everything's async. Once the information is saved, it gives me a callback, I can show it, I can do anything around it. So if I go ahead and save this information, I just tap it out and I see information saved as a text that appears here. Let me go back to the data browser. Pardon the speed. So you see a new demo info class has been created with one entity. And that's the information I've saved, asset and input name. So like in your data schemas, if you work from Hibernate or other ORM tool, your ID is unique. So ID is the first class citizen of any table, and that's how your domain model has been created by Parse Backend for you.
Can we host the Parse in-house? I mean, it looks like this is an external service, right?
Yeah, it is an external service.
Some sensitive data that we have.
Yeah, good question. So you cannot use Parse in-house. What you can do is, there's a very interesting company which does that, and it recently acquired by APG called UserGrid. So UserGrid project, let me come back to that screen. Just give me a second. Yeah. So UserGrid from APG allows you to have your own in-house private backend as a service, which means you can deploy UserGrid locally on your infrastructure if you really want to do that. Which case, where you have more private sensitive information, you don't want to move out the same issues that haunt every cloud provider. If you have them, you can go and set it inside. And what APG also does is, they have moved UserGrid as a backend service, a public backend service, which means you can move your apps running inside or outside. So enterprise apps can work with such kind of environment. Great. So this the way backend services have been simplified by MBAS provider has resulted in very interesting apps coming in picture, and the resultant is very fast development cycles, which means I have been to multiple hackathons where people have built very fine-looking, finished-looking applications in almost 48 hours, and they have a lot of them have actually MBAS running behind the scenes. Hipmunk, Out of Milk, AnyPic, RawChat, some of the most popular applications on the market and on app stores are basically using services like Parse, Kinway, CloudMine, and they have counted growing up, 50,000 plus as I speak. The applications being added in order. A lot of startups building very early applications and demoing with people, understanding how the applications really work. And what they do is they give it out to people as early as possible, have an MBAS platform take care of everything. Once they know how application is being used, they move it out to the internal platforms if they really are good, if they are big enough to manage it.
Is there an open standard? I mean, if we today use Parse and tomorrow wants to use UserGrid or something else?
I have a point for that. I'll cover that.
One more question.
Yeah.
If you want to extend some features, right, like apart from the push service, and how about open extensibility? Is it easy to extend some features that are not provided by them?
Great question. So the two questions. The first question is there standard? Like every common question that comes to using a public cloud service, is there a standard I need to, that these cloud providers, this backend service providers attain to? Second question was regarding extensibility. Can I add new capabilities? First, let me come to this point. I have exactly the same thing which we are talking about. If you are worrying about standards, there are no standards. Please take it, there are no standards. People who give you some kind of hoopla around, there are standards and you can do that, they are just wasting your time. There are no standards. And I don't see this happening. What I essentially see from my experience is mature providers coming in and taking the model like how APG is doing with UserGrid. Okay? Which means you have the same platform running internally. And maybe, so what kind of open standard would it be? Open standard would it be in terms of interaction? So I'm not giving you a proprietary protocol for interaction, you can still go for it. But in terms of using push notification, if I want to use SDK as way of interaction, I am in a coupling with a provider. So how do I reduce provider dependency? This is happening very soon. A lot of mature providers are looking for having in-house implementations that can sit inside. They don't want to open it up, but make it internal. User Grid is one example where User Grid is an open source backend as a service, which means you can manipulate it and add as many number of capabilities you want internally. But obviously, if you want to move it out, you'll only get players which have implemented a certain subset of these features, and they will face the same problem like Android faces with fragmentation. Migrating existing apps is highly complicated. If you're working and you have a mature app, I suggest don't move it unless you have very strong reasons of moving to a SaaS platform. You will also encounter a lot of custom code. Recently, Parse opened up which is called the Parse Cloud services, and what it does is you can actually inject custom code, which means suppose you want to add new capability onto your application and you don't want to allow the user to upgrade the application, and you want to target only specific users. You can inject from your backend code and implementation that can go inside the application and start using it. For example, I want to add capability for a new country as a currency, only for specific countries, for example, or only users of those countries. What I can do using Parse and Parse Cloud is able to design that and only inject into a certain amount of devices, which means you can do a public mobile device management right from the backend, which is really remarkable in terms of how advances have been made in public cloud services. Device and platform support. Very popularly, iOS and Android are the proven choices for these backend as service. WP7 and BlackBerry, some of the services are really popular. Kinway is trying to get WP7 and BB10 coming in terms of its support for the same application for push notification, storage, user management, location services, and social integration. That completes my talk about why you should think about mobile backend as service, why you should be putting that as number 2 priority, try it out. Internally, talk to your developers, pilot it out, and see how easy it is to integrate new features in your application from a backend point of view. And thank you very much, and any questions that you may have.
For the enterprise, is there any backend service which is available as a stack that can be deployed internally and hosted for others?
Yeah, so User Grid is one, Mobstack is working on that. So internally you can deploy it on your own data center and do that.